Okay, welcome to Limits at Infinity. I know, we're in Chapter 3, we did limits in Chapter 1, we did one section in Chapter 2, and here, yet again, another section on limits. Now, as I said before, this one is by far the easiest of them all. What you have to do here is understand what an infinite limit as x approaches infinity, okay? So, when you take a look here, x approaches infinity, okay? That's going negative infinity, that's going positive infinity. So they're going two different ways, all right? One's going to negative infinity, one's going to positive infinity, all right? So those are horizontal asymptotes, okay? Now, here, the limit as x approaches 0 from the left goes to negative infinity, as x approaches 0 from the right goes to positive infinity. Okay, those are vertical asymptotes, all right? So, now, we're going to take x approaches infinity, all right? So the limit as x approaches infinity equals L. The value x approaches number gets x arbitrarily large. So y of L is a horizontal asymptote. So again, how do we find horizontal asymptotes? We did something with the functions, you know. If the numerator was bigger than the denominator is bigger than the numerator, or they were equal. Here we're going to do a little bit different than that, all right? So, here we have as x approaches infinity, 1 over x to any power is always 0. If x goes to negative infinity, 1 over x goes to 0. What that means is, if you have a number, any number, 1, 2, negative 5, divided by infinity, or a number divided by negative infinity, doesn't really matter. Anytime you have a number divided by infinity, they always go to 0. Okay, and that's going to come in play, and it's going to be very crucial on how we're doing these, okay? So, we're going to start with the limit as x approaches infinity, okay, and it doesn't matter if it's positive or negative. So, here's how you do it. Find the highest power of x, that's all you do. You're going to divide every term by that power. So, it's going to look like this. Every term. X cubed is the highest power. Then you're going to reduce it. Okay? So here, that's just 5. Here, a number divided by x to any power. Okay? So x would be infinity. So 27 divided by infinity would just be 0. So anytime you have a number divided by x. Here, this would cancel, you'll get 20. Here, you're going to get, that's canceled, that's x squared. So you have a number divided by x, that's going to go to 0. Here you have a number divided by x to any power, that's also 0. Remember, x is going to infinity in all these. So you're going to get 5 over 20, or 1/4. So your horizontal asymptote is 1/4. And that's the limit as x approaches infinity. And that's how you do these. They're typically not too bad. Where it gets difficult is this next slide. It's when you have a square root. Okay, so you got to watch. You can't just divide everything by the highest power of x. You've got to watch what you divide by, okay? So, what you're going to see is, if you make x squared and you take the square root of x squared, it's x. So it will match up. So usually we look inside the square root, use the highest power in the square root. Typically, that's always bigger than that. Now, there are a few in the book where they flip-flop, where this is x and this is x squared. So it requires a little bit different work. We'll get to those when we get to the book work. So in this problem, we have the square root of x squared over x squared plus 2 over x squared. And we have 3x over x and 6 over x. Again, inside the square root is x squared. You take the square root of x squared to get x, which is why we divide the outside by x. All right. So what you're going to get is you're going to get the square root of 1. That cancels to 1 plus 0 over cancels to 3 minus 0. So you're going to get square root of 1 over 3, which is 1/3. Okay, 1/3. All right. So that one was a little difficult. Again, inside was x squared, outside is x. That's because square root of x squared is x. All right, moving on. Here's one with the square root. Unfortunately, we don't have a denominator, so when we do this, we're going to multiply by conjugate, so that's a minus sign, so we're going to multiply, and again, this is over 1, so we're going to multiply top and bottom by square root of x to the 6th plus 5x to the 3rd plus x to the 3rd, top and bottom, okay? And again, that's conjugate. We did that in previous limits, okay? So the top, pretty easy. This is going to be x to the 6th plus 5x to the 3rd minus x to the 6th. Okay, that's this times this, that times that. So it's not going to be, okay, it's dots, all right? And the bottom is just x to the 6th plus 5x cubed plus x cubed, okay? So now the question becomes, what do you divide by? Okay, what do you divide by? So, well, when you do this, you're going to divide everything by the square root of x to the 6th. So square root of x to the 6th is x to the 3rd. All right? Now, here's a quick little thing up here. That usually happens. Okay, you're going to cancel out your highest power in the numerator. Notice, x to the 6th square root of that is x to the 3rd. So you're going to divide everything by x to the 3rd. Okay? Okay, so you can divide everything by x to the 3rd, except, I'm sorry, inside the square root is x to the 6th. Inside the square root is x to the 6th. All right, so here, this is going to cancel. You're going to get 5. That's going to cancel. You're going to get 1. Okay, that's going to cancel. That's going to be 3, so that's plus 0. That's going to cancel. You're going to get plus 1. So you're going to get 1. So you're going to get 5 on the numerator, square root of 1 plus 1. So you're going to get 5 over 1 plus 1, 5 over 2. And again, this all depends upon understanding that this is a conjugate problem, because you need, for infinite limits, you need a denominator, so multiply top and bottom by a conjugate. Do it correctly, like we've worked on. Here, divide by x to the 3rd, because in the denominator, we have x to the 6th in the square root. Its derivative, or its square root is x to the 3rd. And there, inside, you're going to use x to the 6th. All right, x to the 6th. Okay. So infinite limits, not that difficult. Divide by the highest power of x. The only time it becomes difficult is when there's a square root involved. If there's a square root involved, then what you do is you have to make sure you take the square root of that. That'll be on the outside. Keep that in the inside. When it's flipped and then the lower numbers inside and out is a little bit difficult. I haven't seen that on the final yet. I may assign one and I'll put the work on there so you can see that out of the book.